So actually, last year also, if you have knowledge of this thing, a few people in our branch happened like this. Tanishq was left, and Omkar was also in the situation. His Samsung interview was done, and after that, they told that you are on hold. And the way he was continuously asking to the CDC members, he was continuously connecting with them. They were simply saying you are on hold. They were talking. So the situation was like that. He was not able to do anything. And the same with the Tanishq, he was also depressed. But
Actually,
anyway,
this happened
yeah,
to Parvez.
yes, yes. So anyway, we have to come out the situation. Once we are out of that situation, we can think properly or without any biasing, I can say. So after that, Tanishq again started his preparation and he focused on coming time. Now he's in the you can say Micron, a great placement after that.
Yeah,
A
I know.
long time he took. I can say after placement he took around 6 7 months, maybe I think July he got placed once the placements in the
Mm.
IITs were done in December. So December to July, 8 to 9 months, he was spending time anyhow. So okay, not a problem. This is the time of placements. We will have this circumstances are like that, surroundings are like that. We want immediate success, but sometimes the factors are not supportable. So maybe it may little late, but be positive and keep your motivation high so that if you get any opportunity in future, you will definitely get success. Okay, so this is just can say before starting our discussion, this is kind of simple motivation I can say. Okay, so Revant, okay. Okay, can you just introduce yourself, what you are doing and what you are studying in IITs and which particular project you are doing there?
Mm. Yes, bro. I am Revant and I am from Andhra Pradesh, Tirupati, and I am currently pursuing the MTech in Instrumentation and Integrated Branch in IIT Kharagpur, and I am currently doing the project called Multiphase DC to DC Converter with improved transient response and efficiency. I have also written a paper and a paper called Interconnect Parasitic Resistance with the Power MOSFET layout, and we have submitted it to ISCAS, International Circuits and Systems. Yes, thank you.
Okay, okay, okay. So you mentioned you have done some paper. So
Yes.
something around interconnects. Okay. So
Interconnect, parasitic
yeah, yeah,
interconnect ratio.
parasitic interconnects. So can I understand a little more about that particular paper? That what thing you are targeting, or especially which particular area you are which particular area of the project, kind of RF is going to be the part of it, or any other thing that you are concerned about? Where are you considering the interconnects or parasitic interconnects? I want to
Like
know a little more about it.
In DC to DC converter, we will use power MOSFETs.
Okay.
Okay, for that we need to do the layout, right? After completion of the schematic results, all those things, we need to do
Yes.
layout.
Yes.
In the
Yes.
layout,
Yes.
we will use metals. Okay, for that
Yes.
metals, we will have resistance, parasitic resistance. That
Okay.
resistance we usually neglect when
Okay.
compared to the channel resistance of the power MOSFET. But it is very much comparable with the channel resistance in case of power MOSFETs.
Okay.
That will affect
Why?
the efficiency. That will affect the efficiency. That means that will create some I square R losses that will affect the efficiency of the converter.
Okay. So
That
you
we have.
told that in power MOS there is a problem with this resistance. Why not in the normal circuit is the problem of the resistances of the channel?
Uh, in normal MOSFET channel resistance usually 1 ohm like that, 1 ohm, 2 ohm like that.
So why it is 1 over 2 ohm, not as a mega ohm or kilo ohms?
Like it's
If I'm designing a differential pair, the input devices are of larger size. I want to keep them larger so that their GM is high to get a good noise performance, and I can say better matching conditions to avoid the mismatch due to the input pair. So I'm just trying to make the size of input devices more. In that case, also there is a possibility of resistances. Then why you are not considering that resistances? Why only power MOSFETs will have that resistance?
Like actually, I didn't explore on normal MOSFET, metal resistance, all those things. Actually,
Okay,
I
okay,
am
okay.
working on the DC to DC converter. On that power
Okay, okay.
MOSFET is there.
Yes, 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 I
On that,
got your
I
point.
have checked the channel resistance and metal resistance. Metal resistance is comparable with the channel resistance. Actually, we found that thing, and in order to make it addressable, we have written a paper regarding that. In order to make others know about about this metal interconnect resistance, that metal interconnect resistance actually affecting the efficiency of the converter, that we
Okay,
have
okay,
mentioned
okay.
in the paper.
Okay, so
Usually
do
in
you
DC to
think,
DC converters, that metal
yeah,
resistance will be neglected.
okay, okay, okay. So
They
do
will
you
think
think
like
this
it is
metal
not comparable with
resistance,
the channel resistance.
okay, so do you think this metal resistance is the only problem, or there is a parasitic capacitance are also problem, because the size of
The
power mass is
parasitic
very large.
capacitance also a problem, but
Hmm.
that we can easily measure from the cadence. In cadence, after doing picks, we can do that CCC, coupling capacitors, all those things we will get to know from the cadence.
Okay, okay. So can you draw all the parasitic capacitances associated with the one MOS structure?
I am considering a NMOS.
Okay.
Here, this is gate, this is drain, this is source, and this is body.
Okay.
Will be having capacitance CGD,
Hmm.
and will be capacitance here also will be having, and here also will be having. We usually short this terminal to source body. So we usually ground to reduce the body effect.
Okay. So what are the capacitances you have mentioned? CGD, CGS, and D2B. Okay. Okay. In depth, if I talk about the overlap capacitor between gate to source, gate to drain, and channel capacitance. There are two capacitances in channel actually, without formation of the channel and with formation of channel. There's a device physics, so I'll not go into depth of that.
Mm.
Okay, better. So yes, I can say. So what project you are currently doing in MTech?
Multiphase DC to DC converter, buck
Multiple
converter,
digital. Okay,
buck
buck
converter.
convert. Okay, okay, okay. So good, good. Yes. So now let we start some fundamental questions. Okay. Yeah. So okay. So first thing you have to write this
Okay.
gain expression.
Small signal, okay.
Yeah, obviously gain expression.
Okay.
And second thing you have to ask or you have to write these what we need to say. Okay, output swing.
Okay.
So two things you have to analyze for the circuit.
Okay. B out is equal to, we will short this terminal to ground.
Yes, one thing that I want to make here, don't consider lambda as zero. Also consider body effect.
Okay.
Body effect is also considerable.
Okay. Got it. Now B out is equal to minus GM circuit. V out by V in is equal to, that is small thing, DC gain I am. GM circuit into R out. GM circuit into R out. Here for GM, I will find the short
Okay.
circuit
If the space is not enough, I'll give you the space. Okay, right here.
for GM. I will short the output and then I will apply, not apply. I will find the short circuit current. And then if we find the short circuit current in terms of Vn, that is the circuit transconductance. Can I draw a small signal model and then I will find, or directly I
No,
need
no,
to?
no, no, no. A small signal is not allowed. You have to use your intuition.
Okay, here I will take R out since lambda is not equal to 0. Sorry. Sorry, output is here, right? So here I need to short. I thought of output here. That's why
Okay.
this is ISC. That means current will not flow through this. That means total current have to flow through this ISC. Here current through this MOSFET will
Are
be
you- Okay.
GM into Vin, and also current will not flow through this also. Here this is shorted, this is small signal ground, and this is also ground. Current will not pass through this also. So here GM plus due to body, that is GMB into Vn is equal to ISC.
So,
That means
do
this
you think
GM circuit will
the
be
yeah? Do you think that GMB means transconductivity body will come or not?
transconductance.
Body transconductance will come or not? GMB will come or not in the expression? One see it.
Mm, okay. This is also grounded, right?
Of course.
This is grounded, right?
Yes, yes.
This is not connected to here, right?
No, it is grounded. Grounded.
Okay. VBS is 0. That's why this will not come.
So, what exactly the expression for the transconductor you want to see?
GM. GM.
Okay.
GM. Then we need to find the R out also. From here, we can directly find R out. This is R out. From here, we need to see. That means R out is equal to
Okay, now go on some new page and again draw the circuit. Okay, wait. Now go here and draw the circuit a little neatly, properly.
here I am drawing with mouse. This is R. Since I am finding the R out, input should be shorted to ground.
Okay,
Here I need to find the R out. So here I need to find the R out. R out is equal to upside resistance parallel to downside resistance. So upside resistance will be here. This will be 1 by GM parallel to R naught. So this R out will be 1 by GM parallel to R naught parallel to capital R. This is
okay.
R out, and
So, do you think that in R out expression, the body resistance will come or not? Body term will come or not due to body
body
effect? Something will come or not due to body effect?
VBS is present. VBS is present.
Yes, then.
So if VBS is present, VB equal to 0 or equal to 0. Sorry, GM plus GMB.
Okay, are you sure that it will be plus GMB or it will be one more resistance parallel with these? 1 by GM, 1 by GMB. Are you sure it will be added to GM only, or it will be another parallel term? You're getting now? I mean to say, is it like something
Mm-hmm.
like
I
this,
got it.
or it is something like this that you want to make the point? Which is correct? This one or this one?
PM into VBS.
So, is there any better way you have so that you don't have any such confusion and you directly land at the R out expression or any expression? Because you also
R.
missed this body effect term there in the calculation of GM, short circuit ramp conductor. You're also missing this body effect term here. So, is there any other way or some efficient way where you cannot miss this thing? Without writing a small signal, can you write the equations directly without just looking at the diagram? Because you're missing the body effect term. So something is like confusing there for you.
Its body effect is
So which
confusing.
which is correct? Above and the lower side. This one is correct. Okay, this one is correct or above is correct. Which one is correct? Okay, so okay, I'll tell a way that you can use further somewhere.
Okay.
Whenever there is a like just seat. Okay, wait. Whenever you want to analyze a circuit and you don't want to write anything extra, just okay for like calculation of R out, we want to make these things ground. Okay. Now look at one thing. This is my R, and what exactly I want? I want to apply a test source here because I want to see. So one thing is that I want to apply a test source here, and one thing that is very clear: the lower resistance is R. So I will not take the R. Better to draw the circuit of for this R up only. Okay. So instead of
Mm-hmm.
this applying test here, I will apply test here so that I can exactly find the upside current. Oh, sorry,
Okay.
upside impedance. So better always apply like this. I will not apply any short circuit. Oh, sorry, small signal model. But you see, all three are now grounded. Okay, now
Mm, yeah,
tell
yeah.
me one thing. This direction I am giving to my IT up direction. So always, whenever you want to write the current equation, consider the direction of current, small signal current or whatever large signal current. Always consider direction from drain to source. Okay, always.
Mm,
Or the
yes.
any is a PMOS or NMOS. So now, if I want to consider the direction of ID, suppose ID is drain to source current, this thing is fixed. So ID is what?
Yes.
It is nothing but negative of my IT. One thing is clear. Now, what ID consists? ID consists one GM term, GM VGS. Okay, ID
Mm, yes.
consists GDS BDS, and plus ID consists GMB BBS. So any common thing that you want to see here is now VGS, VDS, VBS. So source is common. First we are writing gate to source, then we are drain to source, then we are writing body to source. So okay,
Mm,
drain to
yes.
source, body to source, and gate to source. Source is common. So you have a knowledge of all the voltage at all the nodes. Gate is ground, drain is ground, body is ground,
All right.
source is VT, source is VT. So we have the knowledge of all the voltage. VD equal to VG equal to VB. These all are ground. Only we have the information of VT as a source voltage. So just put these all values in a single line, you will get the expression. So what I will write? VG, gate is 0 and source is VT. So I will write it as a minus GM VT, because minus will come because gate is 0 and source is VT. Again, for the VDS term, again the minus will come. GDS minus VT, because drain is 0, source is VT. Again for this, minus GMB VT. So what the common thing that we can see, we can take the minus common from both the sides. So we can write
Mm,
GM plus GDS plus GMB. Okay, common is VT. So with a single line, you can see that VT by IT, which is nothing but R up, is the inverse of this particular bracket
mm,
expression. Okay, got the point? So in
mm,
single
yes,
line,
yes.
you must have the knowledge of all the node voltages. Then you can simply write the current has all the components. Three components always current has all three components: GM component, GDS component, GMB component. depending on the node voltage. Suppose my body is ground and source is also ground, then this term will not be available. Getting the point? Suppose
Yes,
drain is
yes,
ground and source is also ground, then this term is not available. Suppose gate is ground and source is also ground, this term is not available. So whatever the node voltage are zero and whatever the difference is zero, that particular component will not be contributing. Rest all will be in the IT. Okay. So from this, what we got R up as 1 upon
1 by GM
GM
plus
plus GDS plus GMB.
GM.
So this point I want to make you, it is nothing but 1 upon GM, or what should I say, parallel, it should be parallel RDS, that thing you were telling, parallel 1 upon GMB.
Yes,
It is
yes.
something like that. Okay, so all three terms will be in parallel. From this, you can directly see with a single equation. And for the GM also, you were like stuck like this only. Now let's calculate the GM for this. Again, apply the same fundamental. Suppose this node is resistor, not a problem. I want to short this. Okay, shorting this, and I
Yes.
want to consider this current ISC. Okay, now this is my V in. For GM calculation, this is 0, this is 0, but input is there. Now I want to know one thing. This terminal is ground, this terminal is ground. So there is no current across the R. One thing is clear. Now all this ID current is nothing but your IC. So I will say my ID is nothing but ISC. Okay. So now
Yes, yes.
I will write the expression for the ID. I told you always write the direction of drain to source. So ID is what? Now I will write first all the components. After that, I will put the equation of the node voltages. GM VBS plus GDS. GDS nothing but 1 upon RDS VDS. Okay. So it's very straightforward. All the node voltage we have known. Like what is GM? What is VG? VG is V in. Okay. S is 0. So in all the equations, S is 0. So GMB, what is this? This is 0. Because body is 0
Mm.
and source is 0. This is also not there. So the body means this is also 0. So always like the single equation, then automatically you can find ID is nothing but ISC equal to GMB, sorry, only GM by V in, and from here we can write ISC by V in, which is nothing but a GM of your circuit, short circuit transconductance equal to GM. So the fundamental or crux of the story is that always write your ID. Okay, ID, all the
Mm.
components, it is a function of all three what? VGS, VDS, and VBS. Always it is a function of all three. Depending on the node voltage, which particular term is available and which is not available, we can write the term accordingly. And after that, you put the voltages, node voltages, because you have the knowledge of all the node voltages. Now, can you apply the same thing if I extend this concept to PMOS? Okay, so this is
Mm.
the PMOS, this is the input I am giving, and here is source resistance that I want to say RS, and here is your drain, and okay, so let's say there is an ideal current source, and I want V out here. So what is grounded? As of now, what is grounded? Okay, I just want output impedance. Okay, I want R out.
R out.
Yes, I want R out.
Okay. For R out. We will open this current source
Good.
and we will apply the test voltage. We will short this voltage, bias voltage. This is RS, and we will short this voltage also. This is grounded. Here we will find IT. This is also IT.
Okay, great.
Also IT.
So,
Then,
so what is the direction of our IT? It is drain to source automatically. It is drain to source. So need not to
yes.
worry about it. Always we have to consider drain to source.
Yes, yes.
Okay.
And here. this potential is IT into RS. This is VSG into
No, one mistake again you are doing. If I've considered the direction from drain to source current, then always write the same equation VGS, VDS, VBS, not VSG.
okay.
Always
For
write
PMOS
VGS.
also.
No, 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 no. The direction is fixed, then VGS. I'll always write the sign will automatically adjust. If your gate is lower, or drain is higher, or source is higher somewhere, higher or lower, the sign will adjust accordingly. But the equation is simple. Current IDS is nothing but VGS, VDS, and VBS. These three terms are basic terms.
Okay. GMB into VDS plus GDS into VDS. Now here IT is equal to minus IT into RS into GMB into IT into RS plus GDS into
Okay, I'll create a
VT
space. Wait, wait, I am giving you more space. Wait, now right.
minus IT into RS.
Okay. So I think now you got the point. What the point I want
Yes.
to make you that always consider a direction for 2 points. Now, okay, you will get the expression, not a problem.
Actually,
So
usually, if body effect comes, then I used to use small signal analysis.
yes, so this is
Small
a very
signal
strong
design.
concept, and I'll discuss in some other video on YouTube as well. People should understand. Always need not to apply the small signal. Once a circuit is complicated, you will be confused. Because we must have the understanding just by looking at the symbol, node voltages, and the IT equation. These are the only responsible things for the complete expression, whether we are calculating short circuit transconductance, whether we are calculating any node impedance, input or output, whatever. Just we have to
Mm.
see these all three voltages, VGS, VDS, and VBS. And after that, other thing. So, okay, Revant, I'll send the link for next meeting because the time is over. The Zoom provides free session only for 40 minutes. Okay.
Okay.
So I'll
Okay.
send one more link. Just we'll join, or it will take some time. So you can take a break of 5 minutes. We'll connect after that.
Okay. I will join now only. You
No, no.
can send the.
No, no. Actually, Zoom takes break. It will allow a second session after 9 minutes.
Okay.
That's why I'm taking just you take. This is a DC again. Okay. So let
Mm.
me check where is our circuit, fundamental circuit. Okay. So this is our circuit. You told the DC again. You opened this CL.
Yes.
Okay. You opened the CL. And so after opening, just the input and output, the difference of input and output is coming as a current, and that current is going to the output. Okay, so we are doing nothing but that current times R out. Okay,
Yes.
so this is a DCN. Okay, now I want what? I want a DCN. Okay, that's fine. Now complete transfer function. So why are you not
Mm.
writing complete transfer function just in a one shot so that this thing I have written is nothing but once you solve it now,
Yeah,
it
but
will give you direct transfer function. And once you have the transfer function, just put s equal to 0, you'll get the DCN. That one thing is over. From that, we have to calculate the UGB and then plot the Bode phase and magnitude plot and condition for 6 dB phase margin. Okay, so now
okay.
come at the fresh page. Come at the fresh page, and I'll draw the circuit again.
I'm
Okay.
directly writing this DC gain pole and zero.
Okay, just I should draw the circuit once more. It is called RL or R naught. Better to. Okay. So now write everything. Transfer function, UGB, and body plot. Positive, negative.
Here, BM into
Your screen not visible to me. Where are you writing?
this side.
Okay, so write around this circuit where I drawn this recent circuit. Now.
Okay,
Then
okay.
you write down here across around this circuit only.
Okay. This is V1 into V out into 1 plus SCL into RL by RL
Okay, okay.
plus GM.
Okay, so what is the expression of transfer function?
Now V naught by Vn is equal to GM into
Okay, write little fast.
RL by. I'm writing with mouse, right? That's why
Okay, so
it's
what you are
taking.
using actually it is not coming properly, your handwriting is not coming properly. What you are using? You are not using pen and pad.
No, no, no. I don't have
Mouse?
that. I am mouse.
Oh, that is the problem. I am just thinking that why your handwriting is not coming that proper.
With mouse, I am writing.
But you should use the pen and pad. You ask someone else because some online interview can happen. Then what you will do? Yeah? This is not a good way of writing. Actually, one should have. Anyone will have. No, you can ask Satya Sai or you can ask anyone. People. Ravi, you can ask. You will have.
Satyasai. They also don't have, I think.
Oh, I think no one has purchased. In our class, everyone purchased. Usually, I think 7, 8 people, all 7, 8 people have taken pen
Okay.
and pad. Yeah.
We don't have that thing. Before two mock interviews also, they also have written with mouse only.
Oh, means with me,
Hmm.
Satya Sai and Pravesh.
Yeah, yeah. This is the thing. Here DC gain will be plus GM into
Okay, Seventh, I got
minus
your
will be
point.
there.
So, okay. So yes, I got your point. Now I'll make you few better way of calculating these things rather than completely writing the expression. You have written the big thing now here.
I
What?
also know that thing actually. Here we can
Yep,
write DC gain directly by opening this capacitor,
that is great.
and here we can directly find the pole.
Yeah. So instead of writing this expression, better to write everything in terms of transconductance than we have written. No. In terms
Hmm.
of transconductance, I mean to say, okay, it will be easy when you know this thing that my this current V in minus V out times GM is coming out, and this current is charging my two caps. Simple. So sorry, this current. Okay, wait. So V out, or better to say, I should say, wait. So this is the current who is charging CS plus G naught, and it is giving me V out. That we can solve. So not a problem, but better to write whenever you are getting some combination. This is my suggestion. Whenever you have some combination like this and anything you're writing, just write it in terms of transconductance. Instead of using R, because what will happen in that case?
Okay.
R parallel 1 upon CS. So solving this is little tedious once these circuits are present in some big circuits. And what better is just write its means conductance down, which is nothing but sorry admittance term, which is nothing but G plus CS. So it is easy to handle. And whenever there is a series combination, like
Then we
then
can
we
write in
can
terms of impedance.
then impedance is better. Okay, then these things are you can so these are something where you can improve or you can do the faster calculations. So overall, the feedback is yes, your concepts are is looking good. But the point is that whenever you commit some mistake, try not to commit these initially because whatever you were writing the current activity, you missed the V out. And in the previous questions, we have seen that you were missing the body effect. So I told you the technique how you can improve on that. And one more feedback that is while you are writing means yeah, along with this mistake is fine, but don't do this initial basic or fundamental. It is not a fundamental mistake. It is just a thing you are missing actually. It cannot be said that yeah, fundamentally going correct. What KVL, KCL you are writing, what GM cell is doing, you are writing correctly, and what other circuits, the fundamental of the circuits you know, the gain calculation you know. GM R out is a gain. But the point is, while you're calculating the GM, while you're calculating the route or the thing, you're missing something. So improve on that. And one more thing, you can be a little faster. Rather, I will not recommend this thing to anyone. The faster or slower is not a point. But yes, in some basic things, if you will follow such things, then your means improvement in calculation can be seen easily. Okay.
Okay.
So okay, fine. Rest. You can brush up your fundamentals more whenever you are solving the RC questions or something else. I think we had RC question. Yeah, this was the RC questions. So see something good about it. You will see when you will solve it at home. Why you are not getting this current across the capacitor directly? You should have the intuition, and every point you analyze it after that. So any such random question can fall. So then you have to be careful. Okay. Like one more question that you can try. Okay. The good question was something. Yeah. Okay. If there is some inductor and some diode comes. Okay. So this was the question, and after that, okay, if there is some resistor, this is diode cut in voltage over 1 volt, and here I'm applying a step of 5 volt. This is your 1 Henry, this is your 1 ohm, and I want to
Okay.
be out. You try it at your home. You note down the question because time is not now enough. I think overall you
Okay.
got some good experience. Just prepare
Yeah.
these fundamentals again and revise the concept more and more so that while in coming interviews you will see questions around this only and more concept that I think we have gone through this five transistor OTA structure. There are a lot of the things should be clear. How to calculate them, how to do the mismatch analysis, how to do the noise analysis, and many more things, swing analysis, and what is a common mode slew rate analysis. So I think you should go through this clearly because they can ask these are fundamental questions. And after the
Okay.
switch capacitor circuits, okay, switch cap
Okay.
circuits. In switch cap circuits, I have given a few questions in the CTQ series also. Some sort of switches are used and some other circuitry. So means some sort of switch capacitor questions with the op-amp. So I posted these
Okay.
questions in CTQ series. You can solve from there. And
Okay.
not many, but yeah, a few other concepts. The five transistor OTA is covered, switch cap questions are covered. Then two-stage op-amp, you can see if someone is interested can ask about the mirror compensation. Hardly someone will ask, but yes, you must have the idea of mirror compensation because the company who is taking an interview, if they are interested in some sort of project or amplifier part, they will go the basic compensation techniques, the Miller compensation basically for the two-stage amplifier. Okay,
Okay.
so current mirror topologies idea you should have this means how your cascoding improves this mirroring action and what are
Cascoding.
the yeah
Wide
what
swing
is yeah
cascoding.
what is the wide swing cascode current mirror and why we use the wide swing what is the advantage there so headroom you will see this headroom problem that
Headroom
we can avoid
cascoding.
headroom problem so there are a few good points that must be on your tips so these are
Okay.
few feedback from my side. Just prepare well again. I'll say all the best. Okay, and hopefully we'll
Okay.
meet soon after your things are done. We'll again come and back. We'll do one more interview session once you are done. Okay, so Raven, prepare
Okay, sir.
well. All the best.
Okay, sir. Thank you, sir.
Okay,
Thank you
okay.
for
Bye.
supporting.
Okay, okay. Bye.
Bye. Bye.
Bye.